So let's begin with collision handling techniques. And the very first one that we are going to see is separate chaining technique. Separate chaining technique. In this, we are going to use a combination as data structure. We are going to use a combination of array plus linked list. So we are going to store data one after the another and link them with the help of linked list. We are going to store data one after the another and going to link them with the help of the linked list. So it's going to be a combination of array plus linked list. Your hash table is going to be array, and then we are going to link this hash table to something called a linked list. We are going to point out to linked list for storing the data. So here we go. We have been given some keys. Keys are nothing but data, as we have discussed, and we have the data to be stored. We need to store 100, 105, 200, 205, 37 and 28 into our hash table. So we need to store this data into our hash table, and the size of our hash table is mentioned right here. It is 10. So our array size is going to be 10. So let's begin. The hash function that we need to consider is rightly mentioned over here. Our hash function is going to be k mod 10. So let's first find the value after applying the hash function. Let's first find the value after applying the hash function. So the very first key that we have is 100. So 100 mod 10, the answer that we get is nothing but 0. So write your answer over here. So this is going to be the hash function value for our data 100. Okay, so this is going to be the hash function value for our data 100, and this is going to be the address location where we are going to store the value. After that, 105 mod 10 is nothing but 5. 200 mod 10 is nothing but 0. 205 mod 10 is nothing but 5, and 37 mod 10 is nothing but 7 and 8. So by now we have found out the hash function values. We have applied our data to our hash function, and we have got the values of the hash function. We discussed previously when we were discussing hashing that the value that we get after applying the hash function is our address, So this is nothing but the address location in our array. This is nothing but the address location in our hash table, which is nothing but an array. So we need to store this data in the hash table. We need to store this data in the hash table's array. So first let's draw a hash table. It's mentioned the size of the array, the size of the hash table is going to be 10. So we are going to make an array of the size 10. We're going to draw it vertically this time. One, two, I'll just draw it right here because we need to draw the linked list. So we have now array of the size 10 ready. So now we need to map this values of ours. We need to store these keys on this particular address location. So we need to store this keys, this data in our required address location, which we have got after applying the hash function. So where do we need to store 100? We need to store 100 in the 0th location. We need to store 100 in the 0th location. So let's store 100. But how are we going to store this? We will point out to a linked list. We will point out to a linked list. Linked list has two fields, you all know. One is data and the next field. So data is the field where you store the data, and next field is the pointer to the next linked list in the list. So right now we don't have any other linked list, so your next part will be null. Your next part basically will be null, but your data part will consist of value 100. So we'll store 100 right here, and this part for now will be null. It will be null. Okay, once this is done, we have stored our first data, first key. We move to the second one. It's 105. The address location that we have found out is 5. So let's store it in 5th location. How do we store it? In the same way, we point out here the address of the linked list will be stored. In this array, the address of the linked list that is created will be stored. We will point out to a linked list. We'll store our data, that is 105, and right now this will be null because no other data is available. Once this is done, we move to our next one, that is nothing but 200. Now 200, we need to store this. The address value that we got is 0, so 0 is right here, but you notice that inside 0 there is something else already present. But this is a linked list. It has a next pointer. So from this pointer, if we add one more linked list, we can point out from this next pointer to that particular linked list. So what we'll do is, we'll create one more linked list, and from the previous linked list of 100, we'll point out to the next linked list and add this value 200. Now this part for now will be null because there is nothing else to point out from the next pointer. So 200 is done. Then we go to 205. Again it's 5, so we come over here. Already 105 is there, but it's a linked list. It has a next pointer. So from that next pointer, we'll create one more linked list and point out to that particular linked list and store 205 data right there. Next we go to 37. It points out to 7. So 7 is right here. So from 7 we'll remove one linked list and store 37 right here, and it will be null because no other value is there right now. Then we go to 28. The value is 8, so we'll go to store it at location number 8. We'll create another linked list at location number 8 and null. This is your technique of separate chaining.